purpose.
Good morning, friends. I welcome you all in experiment part of the subject air pollution and control. In this series of lecture, we will explain the demonstration of different instruments which are used for measurement of air pollution in ambient air. So today I'm going to discuss the first experiment of this series, and the first experiment is your sampling and analysis of PM10 in ambient air using gravimetric analysis. So in order to analyze this, or in order to measure the PM10 in ambient air, we use the instrument that is called as the high volume sampler. Okay, so this is the instrument which we use for measurement of PM10 or RSPN in the ambient air. So I'll explain the different component of this device. So we can see this is the part of the device which is called as the inlet, through which the ambient air is sucked into the device, and after air enters through this inlet, it passes through this part which is the size selective inlet. And the purpose of size selective inlet is to segregate the particles which are smaller than 10 micron and those which are heavier than those. So whatever the particles which are smaller in size from 10 micron, okay, they will go into the filter assembly, and those particles which are heavier, they will be collected here. This is the cyclone, so they will be collected in the hopper of the cyclone. This is the hopper, so here the heavier particle will be collected, and those which are smaller than 10 micron, or we will call them as PM10, will go into the filter assembly. So this is our filter assembly, okay. And in order to suck the air from the ambient, we use this pump, that is the suction pump, okay. So it sucks the air and it creates the negative pressure inside it. And apart from that, this is the filter assembly, and this is your manometer, and along with that a scale bar is there, so through which we can directly measure the flow rate which is passing through this device, okay. And this is your time totalizer for measurement of time. So this is a broadly different component of the device. Now I'll explain the working of it. So when we switch on the device, so what happens? The suction pump sucks the ambient air and it enters into the inlet part. So this is the inlet part, and then when it passes through this size selective inlet, those particles which are smaller than 10 micron or equal to 10 micron will go into this filter assembly. So this part is the filter cover, okay, and these are the wing nuts. So what we do before starting the instrument, we have to place the filter into the filter assembly, okay. So I'll tell the different component of it. So this is the filter cover. We have to take it out very gently, and you can see that here a filter is already present, so it is pretty dark and indicating that some sampling has already been done. So this is the 8 into 10 inch filter, and this is the upper cover. Generally the upper part of the filter is kept as a rough surface, okay, when we are placing the filter over here. And you can see here there is a slot, so the air which is having the PM10 particles, it will come through this slot and will go into this filter assembly, and it will enter through this filter, okay. So whatever the particle which are of the size 10 or less than 10 micron will be collected on this filter paper. So once we place this filter paper gently over here, then we place the filter cover like that, and after placing that, we have to close these wing nut, tighten such that like it should not be disturbed while. Now the important part for ensuring the quality control is that like the filter which is the quad fiber filter and 8 into 10 size, okay. So before placing the filter into the filter assembly, we have to do its preconditioning, and for doing its preconditioning, we kept it at 20 to 30 degrees centigrade, as well as at a 40 to 50% relative humidity for nearly 24 hours, okay. And after doing this preconditioning, we measure its weight, so that is called the filter's pre-weight. And upon doing this, then we place this filter here, and upon placing this filter here, then we cover the filter from the filter cover and tighten all these wing nuts. So now our instrument is ready for doing the sampling, and then we take our instrument into the sampling site, and generally they are at a relatively height, so that like nearby obstacles will not have an impact, and we will be able to get the true ambient air quality, right? So after doing all this arrangement, and placing the filter here and placing the device to our sampling site, we start the monitoring. Okay, so I'll just start the monitoring for demonstration purpose here. So you can see here in this manometer, the liquid is moving up. So through this manometer and through this scale bar, which is directly presenting our cubic meter per minute flow rate. Okay, so we can get our flow rate from this scale bar and the time from this time totalizer. Now, what is the purpose of these two things? Actually, as I said, like we will take the pre-weight and post-weight of the filter, and from the difference of these two values, we will be able to get the mass of the PM10, which will be collected on the filter paper. Okay, but mass of the PM10 will not be sufficient because we have to present our PM10 pollution loading in the ambient air in terms of microgram per meter cube. Okay, so mass per unit volume we need. Now, from where the volume will come? So, in order to get the volume of the air which pass through the device, we have to take the two measurements. The first measurement is from the time totalizer, and second measurement is from the flow rate, which is the taken from this scale bar directly. So the time totalizer reading we have to measure when we start the sampling. So initial reading we take, and when the sampling gets over, we take the final reading of this time totalizer. Okay, so the difference of these two reading will give the total time of the sampling, right? And then from this manometer, we will be able to measure the flow rate of the air which is passing through it. Now the question is like, when we are placing the device in ambient air and we are doing the sampling, initially our filter will be clean. Okay, so there will be a rest resistance for the air to pass through it, and goes further, the filter starts getting dirty. Pressure drop will be relatively high, and because of that, the flow rate will be going relatively down. Now the question is which flow rate we should take. So the point is to take the representative flow rate. What we do, the protocol is that like we generally measure the flow rate at every hour while the sampling is going on. Okay, so what happens, generally this flow rate varies between 0.8 to 1.2 cubic meter per minute. Okay, so let's say we have taken we have carried out the sampling for 8 hours. Okay, then we have taken the 8 representative samples, okay, of this flow rate, and then we take the average of those 8 value. So that will give us the average flow rate, okay, of the device. Okay, is representing the initial weight of the filter, that is presented in grams, and WF is the final weight of the filter. So sure that now you will be able to get the PM10 concentration in the ambient air.